Let's continue our discussion on stock valuation. In the last lecture, we looked at pricing a stock at given points of time in the future. That is a very excellent hands-on skill. But what about pricing a stock in the now, pricing it today? And you could say, well, Chris, I could just look that up on the internet. That's true. You could do that. You could find out what the market has decided that stock price is trading for on pretty much an instantaneous basis, 24/7 nowadays. But let's say you wanted to make sure or check, hey, is that stock price necessarily reflected correctly? Is the market maybe making a mistake? And maybe there's one of those arbitrage opportunities where you can become a millionaire overnight if you find that a stock is not necessarily priced correctly in the market versus your calculations, which you're going to learn how to do here very quickly. Let me tell you that really doesn't exist. And as I mentioned before, if it does exist, it's usually illegal to take advantage of such things. That would be insider trading. Maybe you've heard of Martha Stewart, where people get secret information about a stock that the rest of us don't know and are able to make trading decisions on that stock. And just as a little side point, not really going to address within this course, but you think that making money on a stock is when it rises. You can actually do a position. You can do something called an option, and you can make money on stocks when they fall too. So you can make money both ways. But the question is knowing which direction it's going to go, and being able to do that is very difficult when you're trying to outguess the market. So, and pretty much impossible. Always be leery of people that can tell you that they can make a ton of money in the short term with trading. It's always very questionable, in my opinion. But let's take a look at pricing a stock today and how we would do that. So we're going to jump to the blackboard here and run through a few problems.
All right, well, let's take a look at a problem. We're going to be finding the current value of a stock. So remember, that's our end goal with this. And we are assuming the constant growth model throughout all of this. So kind of set some of the groundwork here. And we're going to be given some information. Again, the one thing we don't know is the stock price, but we're going to get the information from various sources. You could get this publicly today. This stuff is out there. And we're going to use this to plop into that constant growth model, our old friend right down here. We're going to plop this information into there. But let's see what we have. First, we have the risk-free rate. You guys know what that is. Okay, that is that rate of a theoretical riskless investment. What is the riskless investment? It is the U.S. government treasuries, maybe typically. Could be long-term, could be usually long-term treasury bills. That would be your risk-free rate. There is a risk that the government could default, but right now the U.S. government is the most stable in the world, and we are considered the benchmark of risk-free. Okay, so you got your risk-free rate, easily find. You can find that in a quick Google search. You also know the beta of this particular stock. That could be given to you very easily through various stock agencies on the internet. It's almost always reported when you look at a company's information. So you got your beta on that. This particular example we're going to be doing is a beta of 2. We have something called a market risk premium. Now this has been referred to in the text a little bit, but we're going to talk a little bit with that market risk premium. Don't worry, it's super easy. And then we've got the dividend. Okay, dividend, you know what that is. And we know what the dividend of this particular stock is. It's $3. Now, we're going to be given some assumptions that we're going to try to calculate the value of this stock, and we're going to be using the constant growth model. And the first one we're going to look at is, let's assume that we have an expected growth rate of 6%. That's what we don't have listed here. So in our top sections. But let's say we're going to work on the first problem will be an expected growth rate of 6%. That could be whatever your expected growth rate is. Now let's look how we would populate the constant growth model. Do we have the information that we need to plug and chug on the growth model? Well, we've got the dividend, that's for sure. We've got that information, so we're good with that. Do we have the expected growth rate? Well, yeah, we do. We're assuming a 6% expected growth rate. Do we have the stock's required return? What is the required rate of return for this particular stock? That we don't have. So we're going to have to calculate that for sure. And then minus expected growth rate. We got that. So we've got almost all the pieces except for the stock's required rate of return. Now we can calculate that. There is a way to find out the stock's required rate of return. It's pretty painless, but this is going to be kind of a two-step process. We've got to find that required rate of return for the stock, that individual stock, okay? Not the required rate of return for the market. It's the required rate of return for this individual stock. And to do that, we're going to use the security market line equation. And again, we refer to that in the text. It's in there. Also calling back a little bit of our CAP-M. That's a part of that as well. But we're just going to be looking at that security market line equation, which is, again, a really nifty thing to have, and it can tell you that required rate of return for an individual stock. So we're going to have to do some plugging and chugging on here. We're going to have to calculate, in order to calculate this, we're going to have to plug in the risk-free rate. Check. We know that. Not a problem. We're going to have to get the required rate of return on the market. I put a little M in here, but that's actually the market. Okay? We don't have that. We don't have the required rate of return on the market. We've got something called I gave you a little trick here, I guess. We've got the market risk premium, but we don't have the required rate of return on the market in general. Easy, don't worry. Adding two numbers. You probably have figured it out already. And then we're going to have to subtract the risk-free rate. We got that, and check. We've got that, check, and we've got the beta, check. All right. Well, let's go ahead and work on this security market line equation to get that required rate of return for the stock. Up here is listed the security market line equation, just kind of bringing that forward on this slide. Let's fill out what we know. Hopefully you've been following along. You've got a piece of paper, you got a pencil, you're writing this stuff down because we have some information on the first slide that you're going to need to know to plug into this. So let's just put, this is that individual stocks required rate of return, okay, kind of abbreviated, but you know what I'm talking about. Our risk-free rate, that was given to us in the problem. The risk-free rate was 4%. And how do we write 4%? We're going to write it as a 0.04. You could actually, this would actually work even if you didn't convert it and you kept it into, whole numbers, that would work too. But let's just keep with the correct way. So the risk-free rate, 4%, written as 0.04, plus the required rate of return on the market. Now, we were given a couple of numbers, and I said there was a little bit of a trick. We were given the risk-free rate, which was 4%. We were given a market risk premium, let's change that there. Market risk premium. Market risk premium of 5%. All this really is, the market risk premium is the extra oomph, the extra little bit that you're going to be given above and beyond the risk-free rate to be in the market. So that's the premium part of it. So to get the required rate of return is, we're going to just, not high concept math, it's just the two added together. So you're just going to get 9%. So there's the required rate of return for the market. So now you know what market risk premium is. It's that little bit extra above the risk-free rate to, I guess, reward you to be in the market because of the volatility of being in the market. So that little extra bit. All right. So we know that's 9. So we're going to put 0.09 minus the risk-free rate again. Again, you guys can do this, in your head, but I'm going to walk through it kind of slow here. Times the beta, which we know, and the beta on this problem was, whoops, a little bit too much eraser action going on there, which was, the beta was 2. So now we just got to do some basic math here. Not hard at all. 0.04 plus, we'll do the math inside there, and then we'll multiply that. So you got 0.09 minus 0.04, that's going to equal 0.05. 0.05 times 2, okay, so remember order of operations, this multiplication is only going to apply to, what that's going to be. So 0.05 times 2 is going to equal 1.0. And now we just add them together. 0.04 plus 1.0, remember that's actually 4% plus 10%, right? 14%. There you go, or 0.14. All right, not too difficult. There we go. We found the missing piece that we needed to know. We now know the stock's required rate of return. So let's go back to our constant growth model, plug that in, and see what we get. All right, so we've got our constant growth model written back up here. Let's plug it in. So we've got our dividend, which we know was 3, and then times 1 plus the expected growth rate. And in this particular problem, we were just saying a 6%. It could be anything. It could be 10. It could be a -2. It could be a whatever. But we're saying an expected growth rate of 6%. Again, that was given to us. And divided by stock's required rate of return. We know what that is now. That was 14%. We're going to write that as a 1.4. And then minus the expected growth rate again. Do a little bit simplification on this. 3 times 1.06 divided by, do the subtraction there. You can do that in your head, 0.08. And let's get even closer on this. So 3 times 1.06 equals 3.18 divided by our 0.08, and then do that division. Let's see, let me take my calculator out here, and 3.18 divided by 0.08, and we get a stock price of $39.75. There we go. All right, so that's how to solve that problem. Let's take a look at one more example. I want to throw in a negative number. What happens if we have an unusual situation of a negative expected growth rate? Okay, let's assume that we now have an expected growth rate. An expected growth rate of -3%. Could happen, kind of weird, but it could happen. Well, let's plug it into our old friend right over here, the constant growth model, and see what we get. I've written up here, kind of all the info for the problem that we know. the one that we calculated, the required rate of return, and this is on the equity item, the stock, is 14%. So I am bringing some of those abbreviations back just because it's a little bit simpler. Once you get used to them, you can start using them. I think you find them easier. But again, I do like to kind of write it out in English, and it kind of helps conceptualize what we're doing. All right, well, let's plug and chug and see what we get. Our dividend we know is 3. That's not going to change. Times 1 plus the expected growth rate. In this case, that's a negative 3%. So you can do a negative. We're going to do 0.03. I like, just me, this is just what I like to do. I like to put my negatives in a bracket. And then I just be absolutely correct on the number of parentheses. You'd have to put a parentheses there on the end. So that's our numerator. Let's get our denominator. The required rate of return on the stock, which we calculated by using the security market line. So that looked good. So we got our 14. That doesn't change. So we'll list that. Let me list that a little bit better. Minus that expected growth rate. Again, we've got a negative. Not a good situation for that stock. We're going to have an expected negative growth rate. So let's see, what is that stock price going to equal with this? The one thing that might throw you off is the negative. So I'll show you how you're going to treat the negatives, those negative expected growth rates. So it's, again, 3 times 1 plus a negative. Well, 1 plus a negative, anything plus a negative is basically you're subtracting at that point. So hopefully that part's not too difficult, but 1 minus 0.03 is going to equal 0.97. That part should have been easy. Now where it gets a little weird is if you remember how to subtract a negative, and that's what we have going on right here. We're minusing a negative. If you recall back to, I guess maybe 6th grade, maybe 5th grade, when you're minusing a negative, you actually turn it into a positive. It's like a double negative, which is a positive. So in essence, what you're going to have is 14 plus 0.03. Let's do the math on this. And you're going to get 3 times 0.97 is going to equal, double checking my math here, is going to equal 2.91. And when we look at adding, basically, because again you have a double negative in here, what this is going to be, I think you can do that in your head. That's going to be a 0.17. And do the division on that. Let me get the calculator back out. Okay, and 2.19 divided by 0.17 is going to equal a stock price of $17.11. All right, so there you go. That wasn't too painful, was it? Just remember, if you get those negatives, these negative expected growth rates right up here, that the real trick is how to treat the negatives in here, okay? When you're minusing a negative, it turns into a positive. When you're adding a negative, it's just like subtraction. So that one should be more intuitive for you. All right, not too difficult. All right, so we've run through a couple of examples with a couple of different expected growth rates and using both the security market line equation and our expected growth model, kind of in a little two-step process to get a stock price. So a pretty powerful skill that you have. Let's take a look now at maybe changing some betas and see how that operates. Now, hopefully when you see this, you can, if you pause for a moment and think, we're going to be changing the beta. Now remember when we first started, we had a beta of 2. Well, we're going to change that. Let's just say, what would happen if we changed that to a beta of 1? Well, remember how we used the beta to calculate the required rate of return for the stock when we did this and we got our 14? Well, these are all the information kind of from that original scenario. That's not going to be applicable anymore because we calculated that required rate of return on that equity or that stock at 14, but now the beta we used for this was 2, not 1. So we got to go back and recalculate that. We're also going to assume that we're going to have an expected growth rate. We'll stick with that original one, that's 6%. I believe we used 6%. Yeah, we'll stick with that 6% that we used before. So expected growth rate is 6%. We can leave that alone, but we do need to recalculate our required rate of return on the equity. So let's use our old buddy down here, the security market line, and see what we have, what we can get out of this. So we know the risk-free rate. That's not going to change. We've got the required rate of return on the market. We do remember what that was. We calculated that. Let me list that out there. The required rate of return on the market. Remember, we had calculated that at 9%. And the risk-free rate we have as well, so we're good with that. So let's go ahead and plug this in here, 9% minus the risk-free, which is 4 or 0.04, times our new beta. We're going to do 1. That should make it easy. 0.04, and sorry, that's actually 0.04. It should be a plus in there. Plus 0.04 plus. Do the math in there. 0.05. Yeah, 9 minus 4, that's 5, right? Okay. And then times 1. And remember, order of operations, we want to make sure we multiply these two little guys together. In this case, 1 is easy because it doesn't change anything, right? 1 is 1. Anything times 1 is itself. So we'll do that multiplication. Again, that could be anything. Maybe the beta goes up to 4 or whatever, but you would do this, just make sure you do that multiplication with just, order of operations, just right there. So 0.4 plus 0.05, and then that is going to equal 9%. Or 0.09. Okay, so now we have the required rate of return for that particular stock. Now we can go back to the security market line equation. And I'm not going to write it out. You can go back to the other slide. Hopefully you've been doing this along in your own hand, your own pencil and paper. But let's plug that in there. So we've got the dividend, which that didn't change. That's 3 times 1 plus the expected growth rate, which we're going to keep things and still use that 6% from our first example. And that's going to be over the required rate of return on the stock, which we have now calculated that as a 0.09 or 9%, minus the expected growth rate, which that one was given to us. And if we do any problems, that this, again, these information will be given. So let's simplify that out a little bit. Okay, let's see, that's going to be 1.06, and divided by 0.09 minus 0.06 is a 0.03. Simplify that out even more. 3 times 1.06 is going to equal 3.18 divided by 0.03 equals, whip out the calculator, and the stock price is $106. Wow. Boy, that stock price definitely went up, didn't it? So there's another kind of important relationship when you look at with this particular example, and just kind of true in general. You have beta. In this case, we took the beta down. When beta went down, stock price went up. So you have one of those inverse relationships where beta goes down and then price goes up. So there's another little nugget for you to remember in there. All right, so there we go. We've run through a few problems here. We've run through a situation where we were looking at a couple of different expected growth rates. One was a 6%, a positive, and one was kind of the weird one. It was the negative. Remember how we had to do, to start all that off, we had to figure out what the required rate of return of the stock was, and we used that security market line equation. Once we figured that out, whatever expected growth rates that we had, we could use the constant growth model to come up with the stock price. When I threw you for a little bit of a loop and we decided, well, let's play around with the beta, let's leave everything else the same and play around with the beta, that forced us to do a recalculation of the required rate of return on that individual stock by plugging in that new beta, which would make sense. Hopefully you'd figure that out eventually, because you think, well, I used a beta of 2 to come up with that required rate of return of 14, so that can't be valid anymore, so I have to change that in order to plug in my correct values when using the expected growth model. All right, so that one's kind of some complicated steps, but hopefully some pretty easy math, and if you kind of follow along, you should be okay in solving any problems or any scenarios that you might be given in the future.